And we are live. Welcome, everyone, to Hardcore Debugging. My name is Chris Jackson. I'm, of course, not on the slide because I don't do any actual work for this presentation. But it's a session that I invented several years ago with the notion of being, in essence, what Mark Rusinovich does at his Case of the Unexplained. Right? Take that level of depth and ratchet up like 8,000%. And in fact, 401 doesn't nearly do it justice. This is more like 4,001. So let's go ahead and correct that. Make sure it's real clear what we're trying to do here. Because this is Tech Ed New Orleans, right? I don't know if you've ever have seen the slide deck template that's given out. It starts with this slide. I normally think, what a silly slide to bring out, because all it does is remind you what conference you're at. But in New Orleans, that might actually be helpful. But the idea behind hardcore debugging is to present what's possible in the realm of troubleshooting. So the intro course, if you will, is Dr. Mark Rusinovich's course, right? He's your survey teacher, your level 100 teacher, if you will, to the level of debugging. What we're doing here is trying to really ratchet up and say, here is the absolute depth of what's potentially possible. We try to cover a number of different technologies. My friend Andrew Richards, who hosts some really tremendous shows, and he'll talk about his shows on troubleshooting, is here to show a lot of techniques. So hopefully you can take some of these home with you, whether to do them yourselves and extend your repertoire, or to know what you can order your minions to do on your behalf. So with no further ado, Mr. Andrew Richards.
Hey guys, how you going? So as Chris said, my name's Andrew Richards. I am a senior escalation engineer up in Redmond. My job is to debug. That's all I do for Microsoft. I do it for the OEM team. So before you get your machine shipped, they come running to me and say, oops, this thing doesn't boot with Windows. What did I do wrong? And I help them fix it. So I truly am probably one of the very few people at Microsoft who goes all the way down to the motherboard, and I tell them they've got a bad voltage regulator, all the way up to some store application or some web application not behaving themselves. So with that breadth, that's what we're going to cover today. We're going to go all the way down to a blue screen, and we'll go all the way up to a store crash. So we're going to see end-to-end what can happen. When it comes to debugging, it's one of those things that you have to practice, right? It's a skill. It's something you can't pick up overnight. What I suggest you do is do some research. Obviously, I can't teach you how to debug in 1 hour, right? What I can tell you is what training material is out there, what you can do, and how you can educate yourself. I'm going to touch on things so you're aware, but you need to go in depth. This series is a weekly series. Myself, Chad Beater, the guy in the middle doing the Fonzie, and Larry Larson, the person who runs Channel 9. We host it weekly. We've done 43 episodes. They're about half an hour each. We have covered sysinternals tools, all the big boys. We've covered all of WinDBG, the debugging tools for Windows, which we're going to go into depth today. And we've covered Windows Performance Toolkit. And along the way, we've got Mayoni Stevens in to talk about the CLR GC. She's the person who writes the GC for Microsoft. And we've got Amanda Silver in to talk about JavaScript developer, and she's the person who writes the JavaScript engine for Microsoft. Weekly show, as I said, you can always, if you want to consume it really easy, you can use the Channel 9 app, which I don't have installed, and look for it. So what I'm going to do first is, because it's kind of an overview of everything, I'm going to try to give you the scope of what I'm talking about. And this is the scenario I'm talking about. I'm not talking about Visual Studio at your desk debugging an app that you just wrote. I'm talking about something that has released and is out there in the field. You are under time constraints. You are under change management constraints. You are under evasive constraints, which means you can't bring the server down when you're looking at it. So all the things most of the things I'm doing today are non-invasive, which means you can do them live in production. And these are the type of tools that if you ring up Microsoft support, they're going to get you to run. This is how we get to root cause. Now, I'm not going to bother reading this, but it's the standard story of person in trouble, what can I do? The tools are free, that's cool. The tools are about 20, 30 megabytes, and they're not super hard to get onto the box. Main thing is they're Xcopy tools. So you can install the MSI if you want, but once you've done that once, just pick up the folder and dump it on any machine you want. To be clear, we're not using Visual Studio here. You're not going to walk up to a production server and install Visual Studio while it's live, are we? Right? We're not going to reboot the server. Right? We're not going to stop the application. None of these things are acceptable. If this thing's got a once in 6 month issue, you've got to get the data now while it's up and running. We're talking about no private symbols, so you have no real insight into the code, and it goes with that, no source code. And we're going to keep away from high impact. What we are going to use is these tools down the bottom. Those three in the list at the top are all Xcopy tools. You can copy them onto the server without a reboot, without even turning up and add remove programs. Let's do this in the room. Who's heard of the debugging tools for Windows? Who thinks, keep your hand up, who thinks they're an expert? How about Windows Performance Toolkit? So Windows Performance Toolkit is probably the best free tool that Microsoft ships. And I don't know if you saw it, but I think it was on Tuesday, there was a talk called, How Many Coffees Do I Need to Boot My Machine? Right? And they did a pretty good Windows Performance Kit rundown. We are going to use Windows Performance Toolkit today to get to root cause. And last and least in that pile is sysinternals. I'll do my duty to my friend Mark and say, don't forget to go to case.unexplained at 1:15. I believe the queues get horrendous. You should queue like half an hour early for that, otherwise you won't get in the door. We're doing this with public symbols or no symbols. When I mean public symbols, I mean the symbols that Microsoft offer out on the internet. Other corporations, particularly I know Citrix has the same equivalent infrastructure in place. So does people like Google for Chrome, and Apple does it for Safari and stuff like that. And particularly we are doing low impact, which means we are keeping the server up and running. I should grab the clicker. All right, so before we jump into the demo, so I'm going to do 5 more minutes of PowerPoints, and that's it. Like, I'm not a PowerPoint presenter, I am a command line presenter. But I want to set the scope of, so when you go away, download this PowerPoint after the speech. These are the tools you should be using for these scenarios, and I've got about 5 scenarios. Crashes. Everybody forgets the event viewer. I've got news for you. The event viewer tells you why things crash. Don't forget to look at the event viewer. Sysinternals proc dump, it allows you to capture crashes, and we're going to show an example of that today. There is a slight difference between postmortem and unhandled. I'll go over that. Don't forget there's always Windows error reporting in the box. You can configure it via group policy and get the dump files and the crashes on your system to be centrally stored and analyzed. Big corporations centralize their dump files, and then they send them to Microsoft for analysis. Bug check system, the blue screen system, of course, does that. You need to twiddle with that a bit. I'm not going to go over that today, but you should configure it so it's a bit more appropriate. And then we're going to go over how you can use debugging tools for Windows to look at the crashes from user mode apps, which is apps, and the kernel itself, which is bug checks. And you can also use the Windows Performance Toolkit, and we're going to show that as well. Hangs. So there's 2 types of hangs: high CPU, waiting, spinning, and then I'm finally released. And then the opposite, which is wait analysis, where you're waiting for a network packet to come back, a disk I/O to come back. Lots of tools here. Once again, proc dump can help you take a dump file at the right time when those things occur. Process Explorer and Process Monitor both have CPU usage graphs, much like Performance Monitor, which that should be probably in that list. And debugging tools for Windows, we'll use that today to look at a hang. And then Windows Performance Toolkit. Windows Performance Toolkit is an amazingly strong tool, and we are currently in the middle of a series. It looks like there's going to be about 20 episodes on it. It's that big and that deep, and we'll go through some of these today. Performance, slightly different to a hang. It's just a bit sluggish, and a couple more on the list. Tracing. So when it comes to logic issues, file not found, what file was not found, right? Process Monitor, everybody knows Process Monitor? Awesome tool, yep. Great tool for that. And then we're going to show how proc dump is integrated with Process Monitor, which most people don't know about. And then you can do the equivalent in WPT. All right, so when it comes down to actually doing this work, you need to put things on the hard drive the right way, all right? There is a file called dbghelp.dll. This is the engine that knows how to do symbols resolution and look up function names and stuff like that. When you install debugging tools for Windows via copy or install, if you put it into C debuggers, C:\debuggers, sysinternals tools, various other tools know that it's a magic folder name because every single person at Microsoft installs it into that folder, and it will use the DBG help that came with the debugging tools for Windows. The debugging tools for Windows version is the only version that supports symbols. If you mistakenly pull it out of System32, it does not work. All right? So if you're having symbol issues, that is why. And then the last thing at the bottom is how to install that. Watch those 3 episodes of Defrag Tools. Windows Performance Toolkit, roughly the same deal. There's no magic folder name. Install it or copy it onto the box. If you run the MSI, it will add it to your path. We are currently 10 episodes into the series, and there's probably about another 10 to go, as I said. 5 or 10 to go. All right, the next thing you need to make the DBG help stuff work is for the system to know how to actually get these symbols down. There are 2 environment variables. Who knows what set X is? I think it's one of the most unknown. It's set, but it does it at the machine level, right? So it doesn't, you know how you go set name equals blah. That will only happen for that console window. If you use set X, it will put it into the computer settings, right? And /m does it at the machine level. So the top box that you get is user, the bottom box is machine. So this adds it to the machine. Obviously, if you do it at the machine level, you'll need to be elevated. 2 paths. Top one's to do with debugging. What this means is use the SRV protocol, which is something that's only in the debugging tools DBG help. When I download files from that website, which is Microsoft Download, Microsoft.com, download symbols, cache it in that folder so you don't continually have to download it. If you keep on putting star at another folder name, you can have a chain. It's very common that you put a server in your office in the middle. The second one is used for Windows Performance Toolkit. The symbols downloaded in the sim folder get converted to sim cache files, and they also get cached. That cache, I highly suggest that you put it into SkyDrive, because the conversion process can take hours, and once you've done it once, you don't want to wait those hours again. Put it in the SkyDrive. The files are tiny. I mean, you're going to be like 10 megabytes for your whole cache. But I highly suggest you synchronize that centrally. Demo time. That's it for the PowerPoints. All right, so the first one we're going to do is a crash. So in Windows, there's obviously Windows error reporting built in, and it will see that things crash, and you get that dialog and saying send to Microsoft, right? And the way this works is when you start an application, it doesn't matter what type of application, store or desktop or whatever, Windows actually puts a bubble around your app, and it puts an exception handler. So we all know what try catch is. It puts that around your entire app, and that the handler will actually invoke Windows error reporting when something goes wrong. If you don't have any registry key set up, it will just go into Windows error reporting and do its thing. By default, Windows error reporting does not collect dumps, all right? And so you don't really have anything to analyze. All it does is make this tiny little 64K summary, which goes up to online crash analysis and the Windows error reporting subsystem, and goes centrally. If you have an application, I highly suggest look into the Watson program. Get those dump files given to you, right? We will give you a report of what your application is crashing on, right? Find out what's happening. If you do set a registry key, a particular one, you can be a man in the middle, and this is called post-mortem debugging. So procdump from sysinternals, I'm not going to show you how to download it, but procdump has this support. And so what this command line is saying is, when there is a crash, Windows error reporting, please start procdump. MA is a homage to debugging tools, which is a full dump file, which means take the entire memory dump, and install it as the postmortem debugger, and then in this case put the files into C/dumps. And all it's done is what you see on the screen. It's written out these registry keys. Auto means I'm enabled, and debugger is the command line required to that should be run when there's a crash. The top one is 64-bit. The bottom one is 32-bit. It's the same thing as WinDBG -I, and the same thing as Dr. Watson. Remember old Dr. Watson? talk to what's in mind's eye. So let's just do a crash. So I've got a application right here that will crash. Console app, it crashes in the first one line of code. You'll notice that you had a whole lot of things popping up. That was proc dump, catching the dump file. And then you still go through to Windows error reporting. You don't destroy the whole process. You still can use your Windows error reporting infrastructure to tell the central IT department or whatever what to do. And you still have an opportunity to debug it too. So if we look at the dump file made, now depending on how it crashes, sometimes it happens twice. That's just an artifact of the way that the system works. So this thing crashed. Here's the stack. And actually you can see that here's that Windows error reporting code. So what happens is something crashed, it went into the Windows error reporting code, and then Windows error reporting code ran my process. So when I took a dump of the process, it wasn't at the time that the crash occurred. It's way past it. This is the one. Now, Windows error reporting and the debugger and various other things don't have what I'm about to show you, is that proc dump uses a feature that was undocumented in Vista, but it is public, that knows how to wind back the clock, right? So just by typing ECXR, which is exception context record, we have jumped to the line of code. The dump that we've wound back time in the dump file to where we were. And so all the registers are accurate, so you can look at local variables, DV command. Now in this case I had the private symbol and the source code, but I didn't need it on the server. It can crash out there in the real world. I can gather it up, come back to my desk, back to my build server, and then run this command, and then the source code pops up. And as you can see, this is just a null pointer violation. We can do the same thing for a store app. It doesn't really matter how you crash. I'm having so much trouble getting this store app through the store system because it crashes, and they're not really happy about that. It's not really helping me get anywhere. So you can see that crashed, and then I got a dump file. So it doesn't matter how it crashes. It could be a service, it could be a store app, it could be whatever. And with this guy, I don't have the symbols on this box, so I didn't compile it here. You can see that's where the crash was inside the XAML code. All right, so let's move on to the next one, which will be hangs. This is where we're going to spend a bit more of our time. It's a pretty simple concept, right? You set one registry key, get a dump file, open it up, see what you did wrong. This case, it gets a bit more complex. We need to look at the state of the box. We need to look at why the application is hung. And you can have hangs for different reasons. And so you have to be a bit more diverse. So the first one I'm going to show you is an Explorer issue. This actually came from my twin brother, who believes that I'm his personal Microsoft support person. And somehow he seems to have the most unstable PC on the planet, because he gives me a case about every week. I think I'm getting to the point where I think he only calls me for dump reasons, not actually to be my brother. So this is a Explorer dump. Obviously, it's got lots and lots of threads in it. If I use the tilde command, I can see all the threads in the system. At this point, it's only got 9, 0 through 8. If I use the ver target command, I can see that it was a 64-bit app running on the free edition of Windows. This happens to be Windows 7, because I don't like him enough to give him a Windows 8 license yet. And it's only been running for 6 seconds, right? And this is because he had an issue. So his Explorer comes up, he has the taskbar, he has the start menu. But if he presses Windows E, he never gets the File Explorer, the actual files. And it just doesn't matter how many times he presses it, it never happens, right? You go, well, why? I mean, that's kind of a weird state to be in. You kind of expect nothing to show or something, right? You don't really kind of expect this middle ground. So he sent me this dump file. He didn't use proc dump. He just right-clicked in Task Manager and said collect dump. Only works for 64-bit apps in 64-bit Windows. If it's a 32-bit app, task manager it makes a 64-bit dump of the 32-bit process, which is really, really hard to analyze, right? There is a task manager in syswow32, which is the 32-bit version of task manager, if you want to go that way, if you don't want to install any programs. If you just want to do proc dump, you just go proc dump space process name, and it will get it right. Proc dump is architecture aware, and will do the toggling for you. So in this case, what we want to do is look at every single stack. And actually, before I forget to get rid of some of the spew on the screen, I'm going to force a reload of my symbols. So this is where you've seen the matrix. We've all seen the matrix, right? You know how near at the end sees the green bars? That's what debugging gets to at a certain point. You need to know what is or isn't noise. If you do ~k, what you're saying is for every thread, dump out the stack. There's actually another command that most people don't use, which is unique stack. It's the same concept, but if the stack looks exactly the same, it will only print it out once. So if you have a whole lot of workers in your process that are all dormant, you'll see them once, and then it will repeat all the thread numbers. And so for bigger systems like Exchange and SQL, where you've got hundreds of workers pending, you'll collapse your viewing a lot. See how this is not drawn very well right now? That's a bug. We know about it. We're working on it. So this one is relatively flat. And when I say the matrix approach, what you're looking for is stuff that looks fat, right? Workers start at this NT level, kernel level, thread starting stuff. Then it goes usually into some 3 or 4 frames to build up the queue metaphor, and then we wait. This is the user 32 up to the top is waiting. And so what we need to do is kind of like be zen with the dump file and just scroll down. And I can tell you that's a bit simple, that's really simple. Ooh, that one's a bit big. We'll get back to that one. Too simple, too simple. That's nice and meaty. That's nice and meaty. That's really meaty. And that one's a bit simple. And that one's a bit simple. So we've got 3 out of the 9 that we kind of care about. So let's have a quick look at the first one. Start from the bottom, don't start from the top. Stacks grow upwards. So this one's a thread to do with something to do with the shell, and it's currently trying to release something. Well, that kind of is interesting, because you kind of go, well, if it's releasing something, it might be jammed, and you can see the destructors happening. That's what the tilde means. So some type of identity is happening. Then there's some marshalling code, which kind of makes you immediately go, this is going to be something to do with RPC, and lo and behold, there's RPC above it. And we're trying to send an RPC packet to someone, and it's in the single-threaded apartment model. Okay, that can be serialized, and then we're waiting for it. So there's an RPC call there, kind of interesting. We need to keep that back of our minds. In this case, it actually doesn't matter. It just happens to be a current state. This one's irrelevant, and then we have a nice juicy one here. I have a debug extension, which I will share on SkyDrive. I've never done it, and I think it's about time it got shared out. That I say, do the same thing as unique stack, but only show me 20 frames or more, right? And so I'm going to use that just to cut this down a bit. So here's the one of the bigger ones, something to do with the shell, something to do with Explorer frame, some initialization stuff. We're creating a window. Okay, that's kind of obvious. We're trying to make the file explorer window. That would make sense. We're trying to do some navigation, and we're pending some navigation. Okay, that's kind of cool. And then we're trying to activate a particular thing. We need to know what zone it's in. So we know the concept of zone. So we have the trusted zone and the intranet and internet. And so it goes into URLmon, which is the zone DLL. And you can even see it here is get the zone attributes of something. And then it gets to a certain point and it goes load string. So if you want a string resource, that's how you pull a string resource out of a file. And we're going into here, and load resource from alternate module. So you know those MUI files on your hard drive? So we don't put strings inside the DLLs anymore as a Vista. We put them in a separate file called MUI. So that way, if we if we fix a bug, we don't have to release it, was it 27 times for 27 languages? We only have to release the DLL once. And so we call the DLLs language agnostic now, and then they refer to the MUI files. Also makes them much smaller, right? Because you're not carrying all this string baggage with you. So it's trying to open an MUI file, and then there's a thing called the loader lock. Anybody know what the loader lock is? So when a DLL or whatever is being loaded in a process, there's a lock taken out, and only one DLL can be loaded at once. And so when this person is trying to acquire the loader lock, and we know that because we can see enter critical section right here, which is the way that it's protected. So this is waiting for someone. So let's see what this last thread is doing. So another shell one. Well, it's Explorer, not really to be surprised there. And then we're doing some type of reg folder. It might be registry, registered, something. Look, this is public symbol, so you get quite a lot of insight into what the code's doing. Code create instance. Who's all the old COM programmers out there? Yay, go 90s. That's when I stopped programming. When COM became dead, that's when I stopped. I started coding COM without ATL, without MFC, without any helper thing. And as soon as they wrapped it, it didn't become fun anymore, so I left programming. Well, I do assembler for a living. Yeah, it tells you a lot, right? So it's trying to make an instance of something. Here's OLA doing all that type of stuff. And it's trying to load a library. And that kind of makes you worried. So here's a library being loaded. And it's trying to load this library. And we'll go back to why this name's bad in a sec. And then this guy's doing some code. And then he starts talking some XML stuff. Okay. And then he goes into URLmon. So how do you logically go from, I'm learning some XML, now I need to look at URLs. So let's see if we can pull out what he was doing. So probably around here, this is the stack address kind of where we are. So dump by pointer, so look at every pointer from this offset and look for Unicode strings, because everything in Windows tends to be Unicode. And we're going to scan from this here down to around here somewhere. All right, somewhere below this region of code in here. So that's, where did it start from? All right, so let's look down, 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 down. All right, we get some weird funky display because the RTF control doesn't really like printing out some weird characters. And then there we see a file colon. And a bit below it we see a C colon. So it looks like that the first one was given a file name and then it was translated into the file protocol for the lookup. And if we grab this address here and dump it out, we'll get the full name. So this XML opening code is trying to open this lane.xml off the hard drive, and it's turned it into a URL monitored check. And so let's see what's above that and see why that's a bad thing. And it was doing that while it was loading its DLL. So it's trying to do this URL stuff. It's loading some MIME, and we could find out what the MIME type is if you dump out more of the stack. And then it's trying to initialize the URL class, and it's hitting a critical section. All right? And so the other one was doing some URL stuff and then trying to load a library. This one's loading a library and trying to do some URLmon stuff. So can anybody yell out what the issue is here? All right. So for critical sections, which is what this guy is, there is a command for it, bang locks. If you have a hang of this type, first thing on a hang dump, bang locks. All right? This takes a little while to run out. You'll see that we even get a symbol that is the loader lock. We even publicly tell you what the address is of it. There's other locks in this involvement which don't have symbols, and this is purely its address in memory. So we'll look at the top two. That's enough to really suss out what's gone. The loader lock is held by 18FC, and we can see in WinDBG thread number 6 is 18FC, and the zone lock is held by 1810. Right? Now, if you search around on the internet, you will find a debugger extension. I haven't got it on here. I've actually got the internal one. SIEEXTPUB. I don't know what it stands for, but that's what it is. And there's a command called critlist. I actually have the internal one, which is named slightly different, and it will do this analysis for you in seconds, or milliseconds. And there you have it, simple as. Open up a dump file. Now, unfortunately, this debugger extension got deprecated years ago around XP. It still works from experience, not officially, I'm not telling you this, all the way up to Windows 8 and beyond. It's out there on the internet. It's quite easy to find. Download it and have it in your extension repository. When you download extensions, what you want to do is just put the DLL in the WinExt folder. So this is all the ones I've got in my collection in here. So pretty easy, right? You've worked out that there's a deadlock involved, and someone was trying to do stuff in their loader lock, which is a big, big no-no. Was it 6? I think it was 6. And if we grab the module name, which is what that is at the front, and go LMVM, list modules verbosely with a mask of that name. So I could put like asterisk there if I wanted. There's no space parsing in WinDBG. It doesn't matter where you put the spaces. And in this case, you know, my brother's a slack ass. He wasn't willing to buy Roxio again for 3 years. Right? He only sent me this a couple weeks ago. So he needs to be less of a cheap ass and get an upgraded version of Roxio, which isn't 3 years old. All right. So I'm sure it came with a PC, so he didn't even pay it in the first place, knowing him. All right. So, I love my brother, of course. All right, so let's look at an Internet Explorer dump. So what happened in this guy was they brought up a web page, and it had a Silverlight video on it. And you know how you get that dialog saying, do you want to accept full screen? So when he went to go prompt that, it took 90 seconds to pop up, but then it finally popped up, right? And so if we look at this guy, and I'm just going to quickly get to the point and use my command to filter out. Does anybody want this debugger extension, the deep thing? Should I publish it? All right. There's actually a buttload of stuff in here. So roughly, as I do cases and I get sick of typing a command more than twice, I'll write the debugger extension for it. So it's got tons and tons and tons and tons and tons and tons in it. Particularly one of the ones that I do use a lot is grep. So if you know you're going to run a command, so like grep user 32 out of the LM command, and it will just pull it down to that. So out of any command, you can suck it down to something. The other way, which is kind of cool, is you can ungrep it. So show me everything but that. So it's a good way of filtering. All right, so what we're going to do is look at this guy quickly. Deep stacks. 5 deep stacks. Right at the top, we have off the bat, thread number 2. Number 2 is doing if you do an LMVM on AG core, MP control, and all these other ones, you'll see it's a Silverlight binary. He's trying to set full screen, and he's trying to request permissions, and then he is trying to wait for a thread to do the work. So it's kind of obvious that it's meant to be that he's waiting, right? So let's find, so all this junk in the middle, whenever you see junk in the middle, you should be a bit wary, right? So in this case, we've got to have some assembler, right? I can't have this talk without assembler. So let's disassemble that guy. The reason I did that was I want to work out whether that's real code or not, right? That is good assembler. There's actually other junk on the stack, a little bit lower. This is where when DBG loses the plot and can't track back in time, where it doesn't look as good, right? This is, yeah, I can tell you now, we don't use the Pandan, I have no idea, assembler. That's just gibberish in the in some memory that kind of looks like assembler, and in fact, this actually isn't even an opcode. So with, and if you want to be, okay, you go, well, why do we have some assembler in there? Let's find out where it came from. Now, this is a dump file. So there's some commands you can't do, particularly you can't find out if it's backed from an image on disk with a dump file. But it's told us that it is. It's execute read, and it's image backed. And what I can tell you in this case is, because we have a just-in-time type environment, which is Silverlight, This is the code that's been downloaded, just-in-time compiled, shoved into RAM, and there is no file on the hard drive to back it. It is good code. Now, if you're in some application where there's not just-in-time compile, that would be a virus, right, hooking into your system. And we're actually going to see that later. Well, not virus, but helpware. Let's dump out these stacks again. The only problem with debugging is you realize how bad some people are, how far some people are willing to go for that special feature. And yeah. All right, so this guy's trying to wait for a thread. He's got some hex on the stack, which is kind of justified, particularly because it's between some CLR unboxing code on the top. This one looks like a worker thread. This one looks like a worker thread as well. More worker thread. And then we're getting into some guts, right? This one, where's the bottom of it? This is our last stack. Make a thread, something to do with the desk, so that IE has shimmed as in the middle between when the thread has been made and the execution of the thread itself has injected an IE shim to control the thread. I actually looked at that disassembly and it was benign and it's not worth talking about, but I did check it to make sure that it wasn't weird. Because you can't trust that that actually is Microsoft code, right? It could easily be malware or something else. Goes into some Silverlight code, confirm the full screen dialog, make a dialog prompt. Okay, that's kind of what we want. And then we get into the really bad hook. So hooking is the ability for software to basically take control of your program, right? It's not something that you necessarily expect in your program, but don't be surprised to see it. I mean, lots of programs do this. And in this case, it goes up and it does some rich edit stuff, and then we end up being in the rich edit control. So the rich edit control is the RTF control, the one that can do fonts and bold and italic and stuff like that. So we're on this stack, but it's moving, right? There's no weight on the top of that stack. There's nothing obvious. So I don't know that from chance that ran for 1 nanosecond or it's stuck in a loop, right? And this is where debugging has kind of evolved, right? We are no longer really in this static point in time point of view. And equally, taking this dump file took the system offline, right? And we're actually doing work in 8.1 on more live scenarios. So we don't take an outage even though we're dumping. And that will make the world better. But the point is you still have to collect these big files. And particularly if it's something like a big server like 20 gig of RAM, it's a bit too hefty to go that way. So what we can do is use Windows Performance Analyzer instead. Now the great thing about Windows Performance Analyzer is it gives you stacks, millions of them. It gives you addresses, it gives you modules, it gives you processes and threads, and all this information live, right? So it's like you've, particularly with the profiling computation, which is what we've got right here, and what I got the person to do is run Windows Performance Recorder. This one. Oops. That's not what I want. Where is it? I got the person to run, where are we? Windows 8 RTM, Windows Performance Call Kit for 64-bit. All I got them to do is start this program, Windows Performance Recorder, and I got them to choose the CPU one because I was thinking that might be relevant. Press start, capture the dump, a trace for 30 seconds, and then press stop. Actually, for the duration of the Silverlight hang. And what we ended up with was this file. And so what you're seeing here is roughly what you would see in Process Monitor, Process Explorer, Performance Monitor. You'll see the graphs. And I got him to take a dump file outside of this range. So if we go back to the dump file and ask it who it is, this first number is the process ID. So we can turn the hex into decimal. So 17120, which is this guy. And we can filter to that. And so now we're seeing the CPU usage of that guy. Right? So in the middle here, there is a 84-second, that bottom part of the tooltip, an 84-second window of pegging. Right? Let's add threads to the mix. one more vector, and we see code. So we can see one thread going flat chat, and then another one being happy at the end. So this one at the end is 27664, and that top thread, which had the weight, was 27664. So the thread that finally came alive at the end was the guy who was waiting for the other thread. Now, because I made this dump file after the trace, this thread that was made, that rich edit one, it came and went, right? So this one's going to have a different number. But what you can see is all the usage. Now, this wait column is roughly, think it as CPU. And so 23088, and if I get rid of some of these, you can see that the orange is this guy, and which is this guy right here. When I choose a row down the bottom, you'll see how the blue highlights. So every blue point is a stack or piece of data that we gathered. So the darker it is, the more there is in that tiny little window, right? And you can see that this thing was really hot, and then other threads kicked in at the end and were happy. So you can see that there's the one that released and then finally showed the dialogue at the end. So let's work out, from a module point of view, loading. What's going to happen? So what we can do is you can slice and dice the data and say, where did the computation go, right? And what we're going to see is the rich edit control will be off the charts big at the top, right? And so we know that the rich edit control is where the time is being spent. So you might have gone from foo to bar and then into rich edit. Because you see a very low foo and a very low bar, it means you haven't come back down in the stack to come up again, or you have and you've gone up and been up there for a while. Why is this taking so long? Demo glitches at work. Did anybody go to Marko Sinović's talk on Azure this week? Did anybody see what happened when he was apologizing at the end of the speech, when PowerPoint crashed? That was fantastic timing. I'm not going to load symbols because it seems to be running a bit slow with this network. Change it to process and thread. The best way to futz with the column names is to use the editor. I'm going to put that there, and then I'm actually going to get to use the module next. And so here's our hot guy, and we can see that he's spending all of his time in rich edit control, right? And if we go a bit further, whoops, damn it, and turn the stack on, and drill in. I'm not going to do it because it's taking too long. What you'll see, there's actually three functions. There is set start, move, set end. And so it's continually selecting some text, and then moving it. So something is doing that. And if someone's telling someone to do that, it means someone else is busy, right? And so what we can do is use another graph that's available. Because if you're trying to ask someone to do a lot of work, the odds are that you're jammed. And so you can use the UI delay graph, and you can see the very next line of code, this one, this set pointer guy, is trying to do com calls. So you remember how we saw that com thread? So he's involved here. And there's a feedback loop. And this pointer software is continually just thrashing away at this text box, and finally after 91 seconds it releases. And so what the person did was they actually went down one version, this was the latest, and the issue went away. All right, so pretty cool, huh? All right. Time to get into the kernel. So how many people have delved into the kernel in their debugging? Oh, I'm scared. Put my hand up. I'm that guy. The kernel's not that scary. I thought it was. I did Exchange support for years, and then I moved to this OEM team, and they said, yeah, it's all about hardware and what the motherboard's doing, and you're going to debug the firmware, you're not going to debug Windows anymore. and it wasn't actually that bad. So if you've got user experience, don't feel too, jump in there and have a look, particularly when it comes to bug checks. Anybody can work out most bug checks. And the one we're going to look at is this one, 133. It was introduced in Windows 8. Up until Windows 8, we didn't really have touch as a first-class citizen, which means we kind of assumed that we always had a keyboard on the screen, right? Or, sorry, keyboard available. So a lot of debugging you do, you can hit these special keystrokes, particularly Control and Scroll Lock twice. And on new keyboards, there's no scroll lock, you may not have noticed. You can actually override that and use the home key with another registry key. Watch the defrag tools for all that information. And so we used to have this keyboard way of getting out of hangs. Right? The box would be, your mouse might move, but nothing else moves. We've all seen that. And what that's caused by is DPCs. So interrupts fire on electrical circuits on the motherboard. They go into the North Bridge. Remember the old North Bridge on your motherboards? People built their PCs before. You go, which North Bridge do I want to build? So the North Bridge receives that physical electron, and it goes and negotiates with the CPU. Windows supports multiple sockets, so it would choose which socket's going to receive the interrupt. And then it fires a thing called the interrupt descriptor table. And I'm just going to show it to you because this is just geeky, not because you need to know. It's just because it's fun to know. There's a so IDT, interrupt descriptor table. So this is the physical number of the interrupt on the physical pin on the physical CPU. And this is the function that's going to run. You've got to have the screen. I thought I was off the demo already. So this is the physical functions that are going to happen when an interrupt fires. So you remember good old 1992 Command and Conquer, trying to get your LAN working on 10 base 2, and IQ3 and IQ5? Yeah, that's what we're talking about. Here's your interrupt number right here that you set back in those days. And so what happens is the interrupt fires and it runs this routine. This is called an interrupt service routine. And I mention that because ISR is all over the tools, right, over the performance tools. And then an ISR, because it runs at such a high level, so there's 15 levels on a 64-bit CPU and 32 levels on an x86. Programs run at level 0. DPCs run at level 1. Then interrupts fire higher than that, right? If an interrupt is running, or a higher, so if you have IRQ3 and IRQ7, the 7 will stop the 3 from running and will run itself. And all it does is shove its function at the top of the stack and continue running as if it owned the world. And then it comes back, unwinds it, and then this guy continues on, not knowing that he was stopped. And so interrupts will interrupt each other, hence the term, with interrupt service routines. And then they will queue work, because this hogging of the CPU is not good. You want to get the work into the CPU, but you want it to be fair, right? Because the layout of the interrupt controller. They turn into DPCs, deferred procedure calls. We've deferred the work from the ISR. And roughly all it does is queue this DMA address on the physical motherboard from this storage controller needs to have 1 megabyte written from the motherboard, go read it using the HAL, and pull it up into memory. So it's accessible for a file read, for example. They turn into DPCs. DPCs block all applications from running, everything. Explorer, services, you name it. Nothing can run while there's a DPC pending. That's what the mouse is. The mouse is an interrupt, and it's firing a DPC, and the DPCs are scheduled, which is why you still draw the mouse moving. That's why nothing underneath is moving, because all the applications are frozen, because they're not getting time in the CPU. This is exactly what DPC Watchdog's all about. If you get stuck only working on DPCs and make no progress, on a tablet device, there's no way to stop it. Right? There's no keystroke to break out. If it gets into a higher level, which is more at the interrupt level, if you hold down on the surface the power button and the volume down button, that's the equivalent of a hard ACPI motherboard reset. And roughly, it uses the firmware on the motherboard to eject Windows out and stop the box. So if your service is really, really bad, power button and volume down for 10 seconds. All right, so we're caring about DPCs. And so what we do now is in Windows 8, if we notice that DPCs have been running, one DPC has been running for 10 seconds, we will bug check your box. If we notice that an accumulation of DPCs has been running for 15 seconds, we bug check your box. All right? Because there's no other salvation. Before, in Windows 7 and below, you would just be sitting there with the mouse moving forevermore. It would just never fix itself. Or it may come back after a while, but it's not really good for the tablet experience. So let's do a bug check. No, it's not a bug check, a bang analyze. If you pick up anything today, anything, your dump files from bug checks, bang analyze -v. The text on this screen that you get, and also the help, the WinDBG help file is the best help file in Microsoft, without a doubt, right? Look up it in both. Now this is blaming the VM switch, which is the first one that really is not in responsibility of the Windows division, because they never blame themselves. And then you get this one. So we do see these in Windows 8. All these bad drivers from Windows 7 and below who have been hanging systems that have just been... Don't forget, these systems never bug check. They just continually stick there. And so we've never had the telemetry coming back to Microsoft to say, hey, fix your driver. Now we do get the telemetry. We do see these, right? Obviously, the ecosystem is getting better. People are signing up for Watson and OCA. They're aware of their issues. But you do get it. The problem with this one is, see the very first line, how it says 0001? You'll get a 0 when it's a single DPC, and you'll get a 1 if it's cumulative. So you don't know that if the current DPC has been running for 1 millisecond or 15 milliseconds, right? We can get an idea of what the DPC is about by doing a K command, and you can see that we're retiring a DPC, blah, blah, blah. We went to the virtual VM switch, which is Hyper-V. Then it went to NDIS, and then we have a whole lot of more junk at the top. So, whoops. One of the commands you can type is the command kv. The reason why you want the V on the end is not actually for any of that rubbish on the left, which I've never looked at in my life. It's for these trap frames. So remember how I said someone comes in and just takes control of the CPU? Well, you have to remember what the CPU is doing. You have to remember what the registers were. And the way we do that is we insert what's called a trap frame, which is just, Microsoft speak for a bunch of data of what the registers are. The debugger can find those, and so every single time you see a trap frame, it's a usurpment of the process. And so if we look at the bottom, we're in a user program, because the top bit is an F, which means you can tell between kernel space and user space. Some user program was running, so it wasn't even talking in the kernel. An interrupt came in. It happened to be an NDIS one. It went in and out of whoever E1R's driver is, and then went back out. So this will be a mini port driver because it's coming into NDIS and coming out of NDIS, so it's like a callback within the networking subsystem. And then we can see there's a trap here. Right here in the middle, there's some ETL logging. So what I got them to do in this case is go into WPR and turn on logging that's in a circuit buffer, right? And so for the last minute or so of the world, we're recording what's happening, okay? Every millisecond, every CPU is interrupted, and we take a dump of the stack at that point in time. And this is actually it in motion. This interrupt was actually, which is the profile interrupt, was actually usurped by the clock interrupt, which is the only one higher than it, right? Because you've got to keep time moving forward. And the clock interrupt looked at the journaling in Windows and said that that CPU has only been doing DPCs and nothing else for 15 seconds now. Time to bug check the box. And so these trap frames show you different subsystems. This has got nothing to do with the bottom guy in the stack. It's got nothing to do with the DPC that's running at the bottom. It is to do with the DPC running. It's got nothing to do with ETW, and the final blue screen of death is caused by the top bit. So we can get an idea of what's pending by doing bang DPCs. So this guy has, what's that, 10-ish? Other DPCs still not processed. That is bad. If you ever break into a box and see DPCs pending, that is bad. Seeing 10, that is really bad. All right, and if we actually go a bit further, I'll do a clear screen because it's going to scroll a lot. Bang ready tells you on each CPU what thread from a program is pending. And so there's 2 priority 15s pending. There's a priority 8 and a priority 4. 15's really high. So there's a thing called the balance set manager, and you can get what's called a thread inversion deadlock. And so you can have a situation where a thread spinning at priority 8 is waiting for a lock to be freed, and then say someone who's at 4 is just not getting scheduled. But if he was, he would release the lock, and then he would be happy. And so what happens is the balance set manager moves all these 4s up to 15, because 16 and above is real time and reserved. He goes to the top of the stack. He'll finally get this temporary priority boost. He will run, release the lock, and then this number 8 is happy. All right? The fact that you see 15s in here suggests that those top 2 are priority boosted from their normal number up to the top. That's also a big red flag that the system's well behind. And then there's 8 and 4s. 8 and 4s, good numbers, and nothing weird there. You're kind of stuck at this dump. And this is the point where the dump file is a curse to itself. It's a static point in time, and it doesn't really help you. What we can do is look at the kernel file. I should be latest in the background. It's huge. This I need to cancel that. So when you're preparing for TechEd, you do all the right things, and you do your demo 10,000 times, and where is it? Everything's great. And then the night before you leave, you put it onto your laptop because you don't want to carry your desktop. And then you realize that you use 15 gig of RAM to open the trace file, and your laptop only has 8 gig of RAM. And you go, bugger. I have another story. My machine fried on the plane on the way here, and my battery is now dead. I plugged it into the plane, and it fried my battery. So that also was a bit of a moment. And the hardware guy was having a hard time working it out. So that tells you how much I was freaked. All right, so what I'm going to do is use XPerfView instead. XPerfView is what we shipped up to Windows 7. It's roughly the same tool as Windows Performance Analyzer. It uses a much more simplistic data model, and it can't mine as deep. Particularly the UI is a bit ancient. It is a synchronous program, not asynchronous. So as soon as you've got some symbol loading and stuff to do, it takes forever. This is a 3.5 gig file. I've got it on my SSD. It is going to use all about 5, 6, 7 gig of my RAM to open. It will be a bit slow. What we can do is look back in time and say, what has this box been doing? Was this Enders thing running for a millisecond in the past? Has it got this history of running for 10 seconds, right? And it just wasn't at the 15-second mark or just at the 10-second mark individually to put us over the edge. Now, this was run while the system was running, which means the file is not complete. So what you do with Windows Performance Toolkit is you start a trace running, and then you stop it. And when you stop it, it merges in all the symbol information and stuff, so you get function names. This hasn't got function names. This hasn't got any of that stuff. It's actually an incomplete file, which is it's like a log flush without the metadata applied to it. So it's on your c:\kernel.etl, but it's limited. But it still does have enough. And we can see down here in the DPC graph, there's some big spikes in the past. And you'll notice right at the end, there's a whole lot of data missing. And we'll get to that in a sec. Actually, I'll do it right now because it's more fun. So inside the dump file, there is a debugger extension called wmitrace. It really should be called etwtrace, but it's wmitrace. And strdump. And what this is showing you is all of the event tracing for Windows buffers in the kernel. And so what happens is at certain points in time, we flush that out to disk, and it gets added to that file. So that file currently has a lot of data in it, but it's missing the last, whatever, seconds, right, because it hasn't been flushed. Lots of systems in Windows have moved to ETW. ETW was invented in 2000. Windows Performance Toolkit is just a program that interacts with the subsystem. Process Monitor, Process Explorer, Logman, NetSH, Network Monitor, all these guys are just ETW programs interacting with this stuff in the kernel. You actually can see the event log. It actually goes into a stream in the event log, and we can actually print out, let's do the application event log. We actually can print out in the event log what hasn't flushed yet. Right? So when the system came back up again, you can look at the event log, obviously, but it's only got what flashed. This is the events that never got to disk. So particularly with a bug check where it's more like a fundamental crash, you're looking at the event log, particularly you may look at the system one, you could see, hey, I just unloaded this driver, and lo and behold, a millisecond later, I crashed. What did you do when you were freeing memory? Who did you touch? What did you damage? Right? And so you can look back in time and see what's in the event log. This is really slow, unfortunately, but we finally got there. We get the XML output, in Event Viewer, how you can see an XML view, roughly the same thing. In this case, there's a whole lot of WMI events flying around. So these events never made it to disk, but you can see them still, right, in a dump file. One of the things we can do is this top one, the NT kernel logger. That's what we started with XPerf. Well, we started with Windows Performance Toolkit. We can rip that out and put it out to disk as well. So we've got the disk that was flushed, and we can pull out the last 10 seconds and actually have that file as well. Right? And so that's what this other file is on my hard drive. I've actually pulled it out. And we can see the last seconds. Okay, cool? And so you'll see them that have varying lengths because it's dependent on how much buffer was flushed, where they came in the timings. But you can see a little bit more information. All right? Now I'm going to use this historic one. There was a big window. So the timeout is 15 seconds, 9.78. That was kind of pushing the limits, right? It didn't bring the system down, but it was enough. You'll notice that the CPUs are pegged. That's because this system is an OEM system that was put under an extreme amount of stress. 10 times, 100 times more than it should ever do, because we wanted to work out what the breaking point was. All right? This is how you get servers that improve, right? We push them way past the limit, and then we work out what the breaking point was and see if we can tweak that last little bit. All right? So in this case, let's zoom into here. Look at the summary table. And we can see that on CPU 0, which is where all this activity is happening, I'm not going to show you how I got to that conclusion. We have, on CPU 0, all this data, and it's sorted by time. So if we just shove the module on the front, you can see that if we sort it by duration, NDIS was using 4.531, so 4,531 milliseconds. So it used 4 seconds of compute in that little 10-second window we have currently, so about half the compute. Right? And we actually even have the function name. If we put the function there, it only called one function. USB happened to call 2. We actually can copy this because we have a dump file that correlates to the ETL. If we go back to the dump file and use the ln command, which is list nearest symbol to this address, it will actually give us the function name. So even though the dump file was never completed, the raw data is there, and we can go to the dump. Sorry, the trace was never completed. We can go to the dump file to get that information. So we know that it was an NDIS interrupt to DPC, and I'll guarantee you the name of the interrupt service routine is that, and then when they turn it into DPC work, they just append the DPC keyword. So we know that this guy was running hot. Now what we can do is if we keep that highlighted and move the time to the left, we actually have the hottest ones here. So there was a 4.5 and a 2.8. And if we now keep that one selected and sort by time, we actually can see a little window of what happened. And so we can see that the NT kernel was busy a bit, and then NDIS did a 4.5 second run, and then the USB was a bit busy, and we saw that in the DPC list in the dump file, that the USB was pending, and we saw another NDIS. So we know that NDIS is absolutely saturated. And this is really the end of the analysis I can do for you guys publicly. What I can say is I then went and talked to the Endis guys and found out that if you have a system that is at 100% CPU power, when you do TCP sends and ACKs, normally at the application level, the ACK is done by a thread, a normal application thread. What happens is if you are pegging the system so much, Endis realizes I'm way, way behind on my ACKing, which means your TCP receive window is full, and basically no more packets can go on the wire because you've got too many pending acknowledgements. And what happens is when Endis in the kernel gets certain commands, it goes, this system is way, way late. I can't trust threads to get around to doing this, and he picks up the burden. And so the reason why we get this sporadic every 10, 20 seconds gap between the peaks is that Endis goes, enough is enough, I have to do the work now. And it does it at DPC level, which is higher than everything else. And so this work is, it's not bad code, it's just an artifact of an overly saturated system. So in this case, there's not actually much you can do, right? It's a fundamental design decision of Windows to take this precautionary measure to do it. Yes, we could probably have a change request that said, once we get to 5 seconds, stop and let someone else have a go to get away from this, but that's more of an architectural decision. All right, so we've got 10 minutes left. I'm just going to summarize what we've done. Any questions you want to throw out there? Shoot.
I just got a quick question about the two files you had there. Was there any way that you can merge those together?
Yes, you can. So I was going to do that, but I decided not to. So what you would do, where are we? So what you would do is that with xperf minus merge, and in this case it would be kernel2 and the one I pulled out to a file, and then merged.atl. And it will merge them together. Now you can actually merge, I think. All right, so I recorded it with a different version from the one where I extracted it from the dump file. Right? There is actually, I believe, a environment variable that you can set to override that, or a switch. But yeah, you can do it. You get lots of warnings when you open it because it's got no stacks in it, no resolution either. But yeah, you can do it. Now, what you can do is, if you have a client-server system, right, you can trace both ends and then put them together, right? So you can see the conglomeration of two machines. So you can see I was working hot. I did this network call, then he was working, right? And you can do it for any provider. You can do it for xperf has thousands of. So xperf is the command line way of starting it. WPA is the so Windows Performance Recorder is the UI way of doing it. Windows comes with thousands of providers, all right? Thousands. I think we're up to 40,000. See, I do that way too often. But the one that you care about is kernel groups, which is the grouping of them, and filters. And so these are the main ones. So everything that has these capital letters on the front, so these are graphs within the NT provider, which is just one provider out of the 40,000. Those keywords are the ones that turn into graphs in Windows Performance Analyzer. Everything else just becomes a data point with a diamond, right? So it doesn't really have this graphical representation. You can merge them all, so you can see registry keys, you can see file access, you can see network calls, you can see memory allocations. Every memory allocation and every free can be tracked. And if you are interested in tracing performance, memory leaks, logic errors, nearly anything you can think of, I highly suggest you watch the Defrag Show series on this, because I am doing like a 30-minute talk on every single one of those words, and so go to amazing detail. And basically, I'm going to the level that there is no more knowledge past that. I am going to the deepest you can go, right? It's a level 500 talk every week, all right? So let's go back and finish this guy off. Related content. In not very long from now, I have to run over to Channel 9 and tape Defrag Tools Live, which I haven't prepped for. So anybody got any questions they want answered on Defrag Tools Live? Seriously, if you've got a question, go for it.
Now that we are in the mobile and the surface, so what should be your suggestions for debugging here?
All right, so the Surface is ARM, and this also goes with Dell and HP and everybody else who's Windows RT. We do release the Windows Performance Toolkit for ARM. All right, I can tell you now, I solve about 80% of my cases with Windows Performance Toolkit these days. The whole of Microsoft has moved from a debugging approach to a toolkit approach, mainly because of evasiveness and stuff like that. We can't afford to bring systems down. When it comes to store applications on ARM, which is quite frankly all you guys should care about, everything else, pick up a phone, call Microsoft support, and at worst pay $280, at best get it for free. Get us to work it out for you, because we are heavily invested in making sure Surface has no glitches. So I would say pick up the phone. As far as your own applications go, Windows Performance Toolkit is available. You can trace anything you can think of with Windows Performance Toolkit. Windows Performance Toolkit is how Windows is built. Every single day when we build Windows, we have profiles and scenarios that we run through, and if a certain piece of code takes 1 nanosecond more than yesterday, you have to go justify yourself. Right? Which is why Windows has got faster and faster and faster, because this is now a fundamental part of Windows, the Windows build process. As far as your question is concerned, Performance Toolkit and Visual Studio. Visual Studio can debug Surface, right? You should only be doing store apps, use Visual Studio to do it. In 2012, we merged the debugging tools for Engine into Visual Studio. When you're debugging, you can choose to use the GUI-ness that's been around for 20 years. You also can put it into WinDBG mode and do it, what I've been showing with WinDBG. When it comes to SysInternals tools, there is no SysInternals for ARM, and there's no other tools for any other vendor. Talking about SysInternals, I'll be talking about SysInternals a little bit on Defrag Tools Live. I'll be talking about debugging a bit. I'll be talking about Windows Performance Toolkit a bit. If you want to go watch me flounder on stage and not being prepared, I'll be over here in the hall and you can watch me fail, and please yell out questions because I'm going to need something. In case I haven't explained, as I said, it's in the big Borum B, I think over here, the big massive one. Based on the queue for malware, you will want to get there very, very early, like half an hour to an hour early if you want a seat. It always sells out, and they lock the doors when it's full, and they lock the door when it's standing room only. Mark's always a great speaker. He's a good friend. All right, SysInternals Primer, Aaron Margosis. Aaron Margosis is the person who wrote the SysInternals book. Just go buy it. The number of times I've seen someone ask a question, and it's been there on the book's page. Each chapter is not too big, not too onerous. If you have an issue, it will help you. There is a whole lot of cases of the unexplained scenarios at the back of the book. Very, very good book. Aaron talks at 2:45. I don't know if I am or aren't talking in that speech, but I think I'll be going through ProcDump for 20 minutes, all the advanced Windows 8 features that it has. I haven't worked out that yet, but if you want to know how to do what's called exception analysis and exception tracing, that's what this is. And as always, I'll keep on plugging Defrag Tools because it's awesome. And it's also the #1 show on Channel 9 right now. So with that, we'll have to do the mandatory boring slides. There's the Windows track stuff. They're awesome, I'm sure. There's more awesomeness.
You actually don't have to do all those.
Don't you?
Yeah,
So
and I'll point out that Andrew has conveniently elided a couple of additional sessions that perhaps his MC might be presenting later on today.
Yeah, so yours is against Mark, I believe?
Yeah, so for those of you who are into Windows internals, we've got a Windows 8 security internals going into the security architecture behind access checks in Windows 8. That's happening at 1 o'clock. And for those of you who are interested in troubleshooting failing applications, I've got a session called App Compat for Nerds coming at 2:45, and it will absolutely be for nerds as well. So you got a couple of choices if this is your thing.
Yep.
As you're leaving out, how many of you thought this session was way too easy and ought to have been listed as a 100-level session? And how many of you are wondering what that blood trickling out of your ears is supposed to indicate? So I think we've done it about right.
Thanks all.
Please fill out your evals. This is it's a really deep session, so it's kind of experimental how we do it here at TechEd. If you like it and want more, vote for it with your evals. If you want it to be different, right, you can vote against this exact format, but please vote what you would like instead through your feedback and comments so we know how to continue bringing this level of content, because we've heard we'd like it, but it's really hard for us to figure out how do you take the deepest subject in the entire planet and make it accessible to hundreds of people at once. So thank you.